There's a specific kind of fatigue I think we all have when it comes to um, future tech.
Mm-hmm.
You hear about the metaverse or flying cars or, colonies on Mars, and you just sort of file it away in your brain under cool, but not my problem.
Right. It's the Jetsons category. It's fun to think about, but it's not actionable reality.
Exactly. And for the longest time, quantum computing has lived squarely in that box for me. It feels like this
Yeah.
this distant sci-fi science project.
Yeah.
Like maybe in 30 years we'll have these supercomputers that can teleport particles or something, but for now, just background noise. It doesn't affect my Tuesday morning meeting.
That is the default setting for most of us, I think.
Makes
Wake
sense.
me up when it actually works.
But today, we're going to stress test that attitude. We're doing a deep dive into a piece by Johan Steyn titled The Quantum Threat: Navigating the Future of Digital Trust. And the reason we picked this specifically is because Steyn, who's usually writing about AI ethics or education, is waving a massive red flag. He's arguing that the wait-and-see approach isn't just lazy, it's actually dangerous.
And Steyn is a really interesting person to guide us through this because he's not a quantum physicist in a lab somewhere. He's a technology strategist. He looks at the human blast radius of code.
Right.
And his argument here is unsettlingly simple. Quantum isn't coming with a big bang. It's not going to be some Terminator moment where the sky turns purple.
No, he argues it's going to be a slow, quiet erosion.
A silent failure of the one thing we value most online, which is trust.
So that is our mission for this deep dive. We're going to review Steyn's analysis, unpack this, frankly, terrifying concept of harvest now, decrypt later, and figure out why a breakthrough in physics 5 or 10 years from now means your data is actually vulnerable right now, today.
It sounds like a paradox, doesn't it?
It really does. But before we get to the scary stuff, I want to level set on the machine itself. Steyn makes a point to strip away the maths, which I really appreciate. But we need to understand why this is a threat.
Okay.
Because right now, my bank account is encrypted. The file you're listening to is encrypted. Why does a quantum computer break that?
Okay, so to understand the break, you have to understand the lock. Almost everything we do online, sending an email, signing a contract, it relies on something called public key infrastructure, or PKI.
That's the little padlock icon in the browser bar.
Exactly. And under the hood, that lock relies on a very specific math problem, specifically factoring huge prime numbers.
Okay.
So imagine I gave you the number 15 and asked for the factors. You'd say 3 and 5.
Yeah.
Easy.
Elementary school stuff.
Now imagine I give you a number that is 600 digits long. A classical computer, even a supercomputer, is basically just checking guesses one by one. It's sequential. It would take them millions of years to find the answer. That's why we call it secure. It's not that it's mathematically impossible to crack, it's just that the universe will end before the computer guesses the right answer.
So our entire digital world is built on the assumption that the math is just too slow to solve.
Precisely. It's security by exhaustion. But quantum computers, they cheat. They don't use bits, ones, and zeros. They use qubits.
Right.
And because of superposition, this ability to be in multiple states at once, they don't have to check answers one by one. They can, in theory, look at the entire landscape of possible answers all at the same time.
So the problem goes from takes a million years to takes a few hours.
Steyn uses the term tractable. The problem becomes solvable, and once you solve the math, you have the private key. And once you have the key, well, the lock is open.
Okay, so that's the weapon.
Yeah.
Master key for the digital world. But here's the part of Steyn's article that actually stopped me in my tracks. Because usually when we talk about this, we say, well, reliable quantum computers don't exist yet. They're unstable, they're experimental, so we're safe for now.
Right. And that is the trap. That is the exact mindset Steyn is trying to dismantle.
He introduces this concept, harvest now, decrypt later. It sounds like a line from a spy thriller.
It does, but he presents it as a very real, very current strategy. It's a standard intelligence strategy, actually. Think about it.
Yeah.
If you are a state actor or a massive criminal syndicate, and you see encrypted data passing over the internet, trade secrets, diplomatic cables, health records, you can't read it yet, but storage is cheap.
So you just steal the locked safe.
You steal the safe, you put it in a massive digital warehouse, and you wait. You are betting that in, say, 2030 or 2035, you will get your hands on a working quantum computer.
Amen.
Then you just walk into that warehouse and you open every single safe you stole back in 2025.
That completely breaks the timeline. We think of a data breach as I got hacked today, so I'm in trouble today. This is, I got hacked today, and I might not know the real consequences for a decade.
Which brings us to this question of shelf life. Steyn argues this is why you have to care now. If you send a message saying, I'm running 5 minutes late, that data has a shelf life of, what, an hour? Who cares if someone reads that in 10 years?
Right. It's totally irrelevant. But if I'm sending, say, a blueprint for a new fighter jet, or a corporate strategy for the next 20 years.
Or your entire genetic sequence.
Oof. Yeah, that doesn't change.
And that's the harvest now risk. If the data you are transmitting today needs to remain secret for longer than the time it takes to build a quantum computer, then that data is arguably already compromised.
So the breach has essentially already happened.
Yes.
Yeah.
The attackers are just waiting for the decryption tool to finish downloading, so to speak.
That is a chilling way to frame it. And it leads us right into the next big section of the deep dive, the blast radius. Steyn is very specific here. He doesn't just say the internet breaks. He points to specific sectors. And I want to start with the money.
The financial sector, of course.
Yeah. I think the movie version of this is the bank vault hit zero. Hackers drain the accounts. Total chaos. Is that what he's predicting?
Not exactly. It's more subtle and honestly probably more chaotic. He talks about the collapse of trust anchors.
Trust anchors. What does that mean in practice?
Well, think about digital signatures. When you transfer money or sign a mortgage, you aren't physically signing paper. You're using a cryptographic signature that proves I, the host, authorized this.
All right.
If quantum computers can forge those signatures,
Then I can't prove I didn't authorize a transaction.
or the bank can't prove you did. It's a crisis of what they call non-repudiation. If I can successfully forge your digital identity, the entire legal framework of banking just falls apart.
So it's not just that money gets stolen.
No, it's that the system grinds to a halt because every single transaction becomes suspect. Dispute resolutions would take forever. Compliance costs would absolutely explode.
It's a bureaucracy attack. It breaks the handshake that makes the economy move.
Exactly. It turns the friction of doing business up to infinity.
But banking is. I mean, it's money. We can pass laws to fix liability. Steyn moves on to something that I found much harder to shake. Healthcare and education.
This was the emotional core of the article for me, too.
He talks about long life secrets.
We touched on this with the genome idea, but think about a child today. Maybe they have a learning disability or a mental health diagnosis or a genetic predisposition to a certain disease. That's recorded in a school or hospital system now in 2025.
And it's protected by today's encryption.
Today, yes. But if that data is harvested now and decrypted when that child is 25 and applying for a job or running for office or trying to get life insurance,
that information could be used against them forever.
Extortion, discrimination, social engineering. You can't cancel your medical history like you cancel a credit card. Once that secret is out, it is out forever. And Steyn calls this a social failure, not just an IT failure.
That's a heavy distinction. It moves the responsibility from the IT department to, well, to leadership. We are basically mortgaging our kids' privacy because we don't want to upgrade our encryption today.
And it extends to national identity, too. Steyn brings up this idea that trust in your digital identity is essentially trust in the state.
Meaning, if the government gives me a digital ID, and that ID can be forged, the government itself looks incompetent.
Or illegitimate. If you can't trust the digital passport, do you trust the border? If you can't trust the digital vote, do you trust the democracy? It corrodes the entire institution.
Okay, so we've established the mechanism, the math breaks, we've got the threat harvest now, decrypt later, and we've seen the blast, radius money, hell, the state. Now, I have to play devil's advocate for a second.
Go for it.
Is Steyn just fear-mongering? Is this Y2K all over again where we all panic and then nothing really happens?
That's the status check question, and I think he provides the receipts. This isn't just theory anymore.
So what's the evidence that things are actually moving?
First, just look at the standards bodies. NIST, the National Institute of Standards and Technology in the U.S., they aren't just thinking about this. They've already published the new standards. As of 2022, they have identified the post-quantum algorithms.
So the blueprints for the new, stronger locks, they essentially exist.
They do. And you have the UK's National Cybersecurity Centre openly warning companies. They are explicitly saying, do not wait. The fact that these slow-moving government bodies are shouting about this tells you the timeline is condensing.
And it's not just governments, right? Steyn mentions consumer products are starting to appear.
He points to Proton VPN. Now, VPNs are everywhere, but Proton is interesting because they've actually started marketing quantum-resistant encryption as a feature.
That's a real shift. It's moving from an academic paper to a sales brochure.
Exactly. When companies think they can make money by protecting you from quantum, you know the market is waking up. But there was one other detail in the article that I thought was fascinating, specifically about South Africa.
Yeah, Steyn is writing from that perspective, but he connects it to the global stage.
He mentions a quantum communication link that was set up between South Africa and China.
Which sounds like something out of Star Trek, a quantum link.
It sounds totally futuristic, but it's just infrastructure. It shows that developing nations and major superpowers are partnering to lay the physical cables for this now. It proves this isn't just about code, it's about geopolitics.
Wow.
We are literally wiring the planet for the quantum age, while most of us are still struggling to reset our email passwords.
It emphasizes that everything is interconnected. If South Africa's banking rails are vulnerable or plugged into a Chinese quantum system that affects London and New York, there are no isolated networks anymore.
Precisely. The weakest link problem is now global.
So if the threat is real, and the harvesting is happening, and the big players are already moving, what do we do? I don't want to leave our listener just staring at their router in terror. Did Steyn provide a survival guide?
He did, and I really liked his approach because it's not panic and buy gold. It's very practical, very structured.
Break it down for me. What is step one?
Step one is classification. And this goes right back to that shelf life conversation. You need to look at your data and ask, does this need to be secret in 10 years?
Okay, so the lunch menu for the cafeteria,
Not a priority.
the CEO's emails, the R&D files, the customer database.
High priority. Steyn argues you can't protect everything instantly. It's too expensive, too complex, so you triage. You protect the long secret data first. That's the stuff vulnerable to the Harvest Now attack.
Makes sense. Don't boil the ocean. What's step two?
Step two is inventory. You cannot fix what you cannot see.
This sounds painful.
It is the most painful part of cybersecurity, period. You have to find every single instance of public key cryptography in your organization. Every server, every VPN, every third-party app, every piece of old code running in the basement.
It's like trying to find every single key in a massive office building.
And realizing half the keys are for locks you didn't even know you had. But if you skip this step, you are definitely leaving a back door open.
And that leads to the concept that I think is the biggest takeaway from the whole article, a term Steyn uses, crypto agility.
Yes. If you remember one phrase from this deep dive, make it crypto agility.
It sounds like a workout class for hackers.
It does, doesn't it? But it's an architectural philosophy. See, historically, when we built software, we hard-coded the encryption. We poured concrete around the lock. If that lock broke, you had to smash all the concrete.
Okay.
Steyn is saying we need to build systems where the encryption is modular.
Like a replaceable battery in a phone.
Exactly. Or like a modular home. If the front door lock becomes obsolete because a quantum computer breaks it, you want to be able to just unscrew it and swap in a new post-quantum lock without tearing down the entire house.
You want to be able to swap the engine while the plane is still flying.
That's the goal. And that requires a change in how we buy software. Leaders need to stop asking, is it secure? And start asking, is it agile? Can we update the cryptography in 5 years without rewriting all the code?
That's a huge shift for procurement. It's not just about what works today, it's about future-proofing the architecture.
It turns quantum readiness from a science project into a simple procurement requirement.
So we've gone from the sci-fi myth to the Harvest Now reality. We've looked at the blast radius, how it threatens our money, our kids' health data, our trust in the state. And we've mapped out the survival guide. Classify, inventory, and build for agility.
It's a lot to take in.
It is. But as we wrap up, I want to ask you, what is your final verdict on Steyn's piece? Is this just a doom and gloom manifesto?
You know, despite the terrifying subject matter, I don't think it is. I actually think Steyn is trying to empower us.
How so?
Because he's taking the magic out of it. He's saying, look, you don't need to understand quantum mechanics. You don't need a PhD. You need a spreadsheet. You need to classify your data. You need to call your vendors.
It's manageable work. It's boring, unsexy work, but it's manageable.
The organizations that survive this quantum transition won't be the ones with the smartest scientists. They'll be the ones with the best project managers, the ones who treat this as a practical risk program, not as some far-off science experiment.
I like that. It really grounds it. Steyn closes with this sentiment about being responsible custodians.
That really stuck with me. We need to stop thinking of quantum as an innovation topic for the R&D lab and start thinking of it as a responsibility. We are the custodians of digital trust. If we drop the ball now, we break the future.
Responsible custodians. It shifts the burden from being smart to just being adults about our data.
It really does.
So here is where we leave you. We always like to end these deep dives with a bit of a provocation, something to stare at the ceiling and think about tonight.
If you looked at your own digital footprint today, your cloud storage, your sent emails, your health portal messages, what is one piece of data that exists right now that could destroy your life if it was unlocked in 10 years?
That is a haunting question. Is it a financial document, a legal dispute, a medical diagnosis?
Because whatever that thing is,
Yeah.
it's already at risk. And maybe it's time to start thinking about how you're protecting it.
On that cheerful note, thanks for joining us on this deep dive into the quantum threat.
Stay safe out there.
See you next time.